Okay, hi guys. Today we'll continue the differentiation. Okay, so just before winding up the class yesterday, so we discussed about the differentiation of various trigonometric functions. What are those trigonometric functions? Sin x,
Cos x,
cos x,
tan x,
tan x. Okay, so differentiation of sin x is,
minus
say for example, assume this is f of x, then this is going to become, differentiation of f of x will become f dash x. That's a notation, it's being followed. Or else you can also put a d
dy.
f of x by
Yeah.
dx.
Yeah.
That's one way. Alternatively, you can put f dash x. Okay, f dash x is a differentiation of f of x. What is the differentiation of sin x?
Minus cos x.
No, it's cos x.
Okay. For cos x, it's minus sin
Minus sin x.
Tan x, it's secant.
Secant square x. Okay, secant square x. Okay, so what is the differentiation of e to the power of x?
Is 1 by.
Yeah, it is same. Okay, this is very unique function in mathematics.
Oh,
If you differentiate this function, okay, the answer is also also itself. Okay, so no other function follows this one, follows this rule. You take anything, for example, y is equal to 3x plus 2. If you differentiate it, we'll get dy by dx as 3. This is not same as this one. Okay, the differentiation is 3. The original function is 3x plus 2. Okay, so assume this y is y to the power of x. Assume this is one function. Assume y is a function of x. Okay, so if you differentiate it, dy by dx, it's going to be dx only. Okay, the formula for such format is that anything which is in this format, for example, y is equal to a to the power of x, the differentiation of y is going to be dy by dx is equal to a to the power of x into ln a, okay, into ln a multiplied by ln a. In this case, it is also in the same format. Here it is a is a constant, here e is a constant. A to the power of x, the differentiation is a to the power of x ln a. Here also it is the same thing, e to the power of x into ln e. But what is ln e? 1. Because the base is here e, ln. Okay, there is no base given. For natural logarithm, the base is always e. Or else, any logarithm, if a base is not given explicitly, you can assume it as a e. Okay, not 10. Even if somebody says log
and e is
log
2.
20, if no base is given, what base do you take it?
2 point something. That's
No,
e.
you should take e as a base.
Yeah.
Okay, if somebody wanted to give a base explicitly, then they have to write that base. Otherwise, if no base is given, e is the base. E is the default base for any logarithmic function. So ln u, which is 1. So the e to the power of x into 1, that is e to the power of x. Okay, so this is very unique function. Very unique function. The graph of e to the power of x, if you draw it, it's going to be, how is it? It's going to be, at 1, sorry, at 0, it's going to be 1. So it starts with 1 and it goes up like this. Okay, exponentially rising. This is also called exponentially rising. This is f of x. Okay, so this is x, this is y. Then f of x is going to be like this. If f of x is equal to e to the power of x, the graph of f of x is going to be like this. If you differentiate it, and the differentiation is also, because the differentiation is also e to the power of x, so f dash x is also going to be like this. It follows the same shape. Okay, this is the original function. F of x is e to the power of x. F dash x is also going to follow the same route. It's going to follow the same shape. All right, yeah, e to the power of x is very special function. Very special function. Okay, so let's quickly recap yesterday's some of the problems. So for example, y is equal to 3x to the power of minus 2 by 3. So what is the differentiation of it? I'll put it as f of x instead
3
of
times.
f dash x is going to be
3 times.
3 times
minus 2 by 3.
Minus 2 by 3 x.
Times x.
The power is reduced by 1. So minus 2 by 3 minus 1. It's going to be 3 minus 2 minus 3 minus 5 by 3. Okay, it will be minus 5 by 3. So if you want to simplify, you can simplify it. 2 gets cancelled and you will get minus 2x to the power of minus 5 by 3. Okay? Okay. Say for example, if f of x is equal to 3 into 5, what is f dash x?
It is 0.
Exactly, it is 0. Because 3 into 5 is 15, which is constant.
Oh yeah.
If you differentiate any constant,
But
to
what's
confuse it, you can, somebody can give it like that. There's no x, it's not x, it's a multiplication.
But what's the differentiation of like 15x?
15x, the differentiation is 15, but there is no x here. Okay, so it is a constant. To confuse, somebody can ask a question like this. Okay, you should be strong in fundamentals. Okay, so this is one thing. For example, if something is given like this, say f of x is equal to 3x minus 2 by x square plus 1. How do you differentiate this one with respect to x? With respect to x. So what is the variable here? We should always differentiate with respect to, yeah, usually that is a convention. Okay. Okay. So what is the formula? If some function is in this format, u by v. Of course, this is all the function of x, but this function can be broken down into a numerator and denominator. Okay, numerator is a function of x, again denominator is also a function of x. So in such case, assume this is u, assume this is v. So the formula is v, that is the denominator, yeah. And the differentiation of this one, what is it?
It is 3.
3. And?
Minus 2.
Huh?
Sorry, 3x.
Minus 2.
3x minus 2.
And the differentiation
of x squared minus plus
is
1.
2x.
2x.
By
x squared plus 1 whole square.
Whole square, exactly. Yeah. Okay, simplify it. Okay, so multiply it, simplify it, and whichever times you can club it, you club it. If not, you leave it like that. Say here you will get 3x square. Here also you will get 6x square. Because this 3x square and 6x square, you can simplify it. Alright, say for example, instead of this one, somebody is given like this. How you do it?
Bracket and half, like the bar half.
What do you do? Exactly, yeah, this can be written as
whole to the power of 1
3x minus 2 whole to the power of 1 by 2 by x square plus 1. Now you apply the same rule. So x square, f dash x will be, this is same f of x only, but you have written in a base and a power form, exponent form. Okay, so for which we already know the formula. Okay, so now what is the formula here? This is function of x, this is function of x. It's a
1
fraction.
by 2. X square plus 1.
First to this one, x square plus 1.
X square plus 1. And times.
And the differentiation of this one. What is it? Half 3x minus 2 reduced by 1. Power reduced by 1. Half and minus 1 by 2.
Minus 1 by 2.
Then?
Plus. Sorry, minus.
No, that's fair. That's why I've intentionally given. So you did this differentiation. And the inner part also you have to do the differentiation.
3.
Okay, don't leave it like that. Okay, so 3.
Into 3
minus. This whole thing.
3x minus 2.
3x minus 2. You can put it as a square root, under square root. Because it's easier to put, but if you want, you can still do it. And then the differentiation of x square plus 1, which is 2x, by x square plus 1 whole square. Okay, so this is the key. Okay, now we clubbed both these things. Say chain rule is involved here, and also a division rule, u by v division rule. Okay, so any function, if you want to differentiate it, you have to see like what rule to apply. Okay, immediately looking at it, you should see like what rule to apply. See here, square root is given. There is no formula here directly for a square root, but instead you write it in a base and power form. Okay, the base, this is the base, and this is the power form. Then it's easy to differentiate it. Again here, the chain rule you have to apply because this is an inner function. You can consider this as inner function, and this inner function is getting squared, rooted. Okay. All right, yeah. Say, okay. Sin x is equal to cos x. Sorry, the differentiation of sin x, d sin x by
90
dx. What is the answer for this one?
com. It it is cos x.
Differentiation of sin x cos x.
Exactly. Yeah.
Cos x by cos x. That's it.
That's it. Okay. Number of ways, but instead of putting dy by dx, instead of defining y as a sin x, I directly put sin x here. Okay. Directly put sin x here. All right. So you know sin x differentiation, cos x differentiation, but tan x differentiation also you're aware. So if somebody gives what is the differentiation of secant x, these are the main formulas are given.
It is
it minus tan x?
Minus tan x.
No.
Secant.
Tan
Secant
squared
x.
x.
Say for example, y is equal to secant x.
Oh, it is the square root of minus tan.
No.
Tan squared x.
See, this is the differentiation of this one is secant square x. What is the differentiation of secant x?
Tan x by 2
Half.
times.
You cannot derive this way. By looking at it, you cannot tell the differentiation of it. So you look at it.
So
See, the differentiation of sin x is cos x. From this, can you tell the differentiation of cos x? You cannot tell. How come this minus came in and where is it came from?
So d like.
Yeah, so the same thing you can also write as 1 by cos x. Isn't it? Secant x, you can write it as 1 by cos x. That's where you need to manipulate the things as per your requirement.
How did you get cos x?
Secant x, what is the formula?
Yeah.
The main trigonometric functions. Secant
But you
and
asked
cos
the
is
differentiation of.
correct. We will do the differentiation of y. What is y? Y is secant x. Let's do differentiation of y. What rule we should apply here?
U by v.
U by v. So cos x,
Cos x.
differentiation of 1,
which is 0.
0 minus 1, differentiation of
Cos
x
minus sin x.
minus sin x
Divided by cos x whole squared.
cos square x.
Cos squared.
Cos x whole square and cos square x both are
And
same.
0 minus.
So 0 plus sin x by
Cos square x.
cos square x. How can we further write? 0 plus sin x is sin x
by
Sin x
by
cos squared x.
cos square x. Cos square x you can write it as a cos x into cos x, isn't it? Can we write like this? Cos square x. So sin by cos, what is it? Tan x.
Tan x.
1 by cos x. Can we say that?
Times cos x whole to the power of 1 minus 1.
Sin by cos is what?
Tan x.
Tan x. And how about this one?
1 by cos x.
Secant cos x. If it comes up,
Oh yeah.
it will be
1 by cos x is
minus
secant
secant x. Yeah.
Exactly. Yeah. Secant x. Okay.
Tan
This
x
is the-
secant x.
Yeah. So the answer is tan x secant x. See, it's a bit complicated, but this is
It's
how it
weird.
is. It's weird, yeah. If you look at it first time, you see it's a
Like
strange.
the differentiation of secant x is tan x secant x.
The differentiation of
Secant
Secant x is tan x
secant x.
Yeah,
secant
it's like
x.
2x like
Yeah.
Okay. Also to illustrate what is the sine graph. So this is going to follow like this. So where is the slope highest here? Say let's analyze only this part up to 90 degrees. Where is the slope highest? This part, initial part, or here, or here, or here?
At the
No, at the tip the slope is 0. That's why
yeah.
it took a U-turn.
Yeah.
Okay, the slope is 0. Where is the highest?
Zero.
Yeah, initially the slope is very high, and after that it is rising. But the rate at which it is rising is to slow it down, and eventually it is slowed down. The slope has become 0. The slope is high here. Slope is here, high here. So what is the differentiation of it? Sin x. This is sin x graph. Okay, sine wave. We will also call it as a sine wave. So what is it? This is f of x. You can say f of x is equal to sin x. What is f dash x for sin x? Cos x. What is the graph for cos x? So it's going to be like this.
Okay. What? Sine.
This is sine x graph, sine wave.
Yeah.
This is a cos wave,
Yeah.
isn't it? Cos 0 is 1, cos 90 is 0. Here the rate of change is very fast here. So that is why it started with a high value, high slope.
Oh, okay.
Here the rate of change is become 0. That is why the cos has reached 0 here. This is f dash x, which is cos x. This is f of x, original function, which is sin x. This is f dash x, which is cos x.
Yeah.
I am also explaining why this has become a cos x. Why the differentiation of sin x has become cos x. I am explaining. Listen to that explanation. So here the slope is very high initially.
Very. Yeah.
That is why the slope is, it started with a high value, cos.
Oh, okay.
Understand? Did you understand this?
Yeah.
Here the slope is very high. As you go to the top, the slope has slowed down and the slope is 0. That is why if you differentiate this f of x, if you differentiate sin x, you'll get a cos x. If you plot a cos x graph, it will look like this one. You know this cos x, how it is going to look like. But to justify why the differentiation of sin x is a cos x, this is how you have to understand. The sin x, the rate is very fast here, very high. The slope is high at the beginning. And here the slope is 0. F dash x is nothing but the slope of this function. It started with the high slope. As you go down to the 90 degrees, it becomes 0. Does it justify why sin x differentiation is cos x?
Yeah.
You justify it, right?
Yeah.
Can you explain again why we got a cos x? Sin x differentiation, why? Can you justify it
Because
again?
it is like it is the slope
This-
is like
The
high,
slope is
high.
the slope is really small when it starts, and then as it goes down.
The slope is high when it starts.
Oh, I'm talking about the cos one.
No. This is the original function. This is the differentiated function.
Yeah.
The slope is
For
very
sine,
high
it's
here.
very high at the start, and
That is why that
When
we
it-
started with the high. As you go down, the differentiation of this one,
It
is
decreases.
decreased, and at this tip it becomes 0.
Yeah.
That is why this is the differentiation of this one. Okay? Okay.
Then why for cos x the differentiation is
It's minus sin x. See here the slope is what is happening? It is falling, it is reducing.
falling
That is
and
why you got a
reducing.
minus.
Like, there it is.
Yeah.
If you put this one here and this one down here, it is a minus because it is falling. The slope is falling. Okay. First you understand this one. After that you can visualize like how the cos x has become a minus sin x. Okay. There might be proof how to do it, but this is how you can simply understand and realize and justify your answer why the sin x differentiation is cos x. Okay. This is how you need to convert these trigonometric ratios to put it into any of those forms and then solve such examples. Very important, like if you understand, you got a very good grip, which means that you can master yourself if you understand why f of x, why sin x differentiation is a cos x. You can really master in differentiation if you understand it. Okay, the slope is higher here at the start. That is why the cos x started with very high, and as you go to the 90 degrees, the slope is 0. That is why at 90 degrees the slope, the value of cos x is 0. Okay, as you go up, slope is decreasing. That is why the slope is falling down. This is not the sin x, this is the slope of sin x. The value of slope axis, if you point it in a graph and connect all those points, it follows cos x shape. It follows cos x shape. Yeah. Right, yeah, okay. Let's quickly take y is equal to sine 4x or maybe sine square 4x. Okay, let's do it.
dy
By dx.
yeah.
What is the answer?
Oh yeah, 2 sine.
Like that. Teresh, you
Two.
also speak up, yeah, please.
Sine x is cos x. Is it
No.
cos
The
squared?
number of formulas you need to
Cos-
apply here. It's not just a one formula.
2 sine and then
Why
four,
did you
four,
get 2?
Is it not like something like x to the power of
sine
n?
and then 4.
Oh yeah.
2 sine
2 times
4.
sine. 2 minus 1.
Mm.
1.
Mm.
2 times sine.
4.
4x.
4x.
So that's one part is done.
And
Go again the inner function. What is the inner function? Sine 4x.
sine 4x.
What is the sine of 4x? Differentiation.
4.
Cos
4x.
Cos 4x.
Oh yeah.
Cos 4x. Is it done? No, it's not done yet. Again 4x is there. You differentiate it again. See how lovely these sums are.
Again, there
Okay,
is 4x.
there's a lot of scope for thinking and
It's 4.
4, yeah, into 4. Okay, if you want, you can multiply this one here. Multiply it by 4. Okay, the 4 2s are 8. 8 sine 4x cos 4x. See how nice it is? Again, so start from the beginning, like why you missed to think that previously. Why it did not come to your mind. Again, dy by dx. What went wrong in your previous thought process and how you can correct it now?
2 sine
2 sine 4x.
2 sine 4x.
4 and then cos.
Why we got sine 4x?
Because that's the power in
Power is
sine.
reduced by 1.
2
2 minus
1
1 is 1, so you don't have to put any power, yeah. And then
The differentiation of sine 4x.
is cos 4x.
Cos 4x. And then the differentiation of 4x, which is 4.
Which is 4. Very good, yeah. Okay, simplify it.
Thank you.
F of x is equal to 2 sine 3x plus 5 cos 2x. So f dash x. What is f dash x?
Oh yeah. Are like the each one, right?
Do each one because it's a
Yeah.
sum of two functions. Sum of two functions. So you can individually differentiate it and put
2
plus.
times.
2 times. Because this is a constant
Cos
coefficient. You
3x.
can keep it aside.
Cos
oh, yeah.
3x.
Cos 3x.
First, let's do 2 sine 3x and then let's move on to 5 cos 2x. Or will we do like, will we?
So, okay, so sine 3x, cos 3x. Is that all? Are we done with this one? This part?
No, we have to do the
Inner function. What is inner function?
3x.
3x. What is the function?
3.
What is the 3? Yeah.
3 times 3
Okay.
plus
5
5
cos 2x. What is
minus sine 2x.
Minus sine
2x
2x times
2x
2.
2.
2. Don't say with the doubt. Okay.
And
6 cos 3x. How we got? 6.
3 times 2 6.
3 times 2. 6 cos 3x. And here?
Again, why did you get 3x? Oh, that's the
This is cos 3x.
yeah.
2 times 3 is
Oh
6.
yeah.
And here, what do we
Plus-
get here?
5 minus 2. Sorry, minus sine 4x.
Minus sine
4x. 5 times minus sine 4x. Or 10 times.
10 times, yeah. So again, I said like previous
Why
yesterday
can't we
also
just
we
multiply
should
them?
not multiply this one.
Okay.
This is, the 2 is multiplying the whole thing, like the ratio of the whole sine ratio. It's not multiplying only the just the angle. Okay, it is multiplying the whole part of sine minus sine 2x. In such case, 2 multiplied by 5, which will get minus 10. Here minus is also there. And then sine 2x. Okay, so you need to practice a lot. Practice a lot and it should come to your mind very quickly. Okay, so f of x is equal to tan to the power of 7x. Yeah, what is the differentiation of it?
Secant
7.
squared
No,
whole
7
7. Sorry, 7.
7.
tan and 6x and then e can square like
And then
secant
secant square x. Yeah.
yeah.
Okay, this is the answer.
Why did you get secant square x? It's
Because the tan x differentiation is secant square x.
and
That's the
tan
inner
x
function.
is the inner function.
Tan x is an inner function.
Why not 7? Oh, 7 is just
7 is like it's in
Yeah.
a form of x to the power of n. The differentiation of x to the power of n is n into x to the power of n minus 1. Okay, so another one, cos f of x is equal to sine pi plus theta cos theta minus pi. Okay, looking at it, you may confuse, like you may be afraid to solve it, but if you jump into it, it will not be that difficult. Okay, so f dash x, the differentiation of f of x. What formula we are going to apply here?
U
into
times
like
U.
UV, yeah.
yeah.
So this one, this one, sine pi plus theta, the differentiation of cos theta minus pi. What is it?
Equal to minus sine
Minus sine theta minus pi.
yeah.
Okay?
Yeah.
Minus sine theta minus pi. That is one part. And the next part is plus
Yeah.
cos theta minus pi. So, oh sorry. Are we left with it? Like we need to do the inner function differentiation also. What is the inner function differentiation?
Is the inner function theta minus
Theta minus pi. If you differentiate that one, what do you get? What is the differentiation of theta?
I
With respect to theta, what are we doing here? F dash x.
F dash x.
Sorry, f dash theta. Sorry, f theta. This is f dash theta.
so it is I
No. What is the differentiation of theta minus pi with respect to theta?
oh yeah it is yeah minus pi.
No.
Is it for cos? Like the theta is.
See, it is in the form of u and v. U is one function of theta and v is another function of
Yeah, but
theta.
theta minus pi is the inner function of.
Theta minus pi is the inner function. So what is the differentiation of theta minus pi?
Zero.
What is the inner function? Theta minus pi. What is the differentiation of theta with respect to theta?
1.
1 minus, what is the differentiation of pi with
Pi.
respect?
With respect to theta.
What is the differentiation of pi with respect to theta?
1 pi.
It is 0. Pi is a constant.
Yeah.
Okay, pi is a constant. Okay, it is 0. So what is missing here?
1.
Yeah, what is missing here? Why you're not able to answer? Okay, next. What part? We're done with the differentiation of this one here. Now, v is the second function, cos theta minus pi, and the differentiation of sine pi plus theta. What is the differentiation of sine pi plus theta?
Cos pi.
Cos
Pi.
pi plus theta, and is that all?
1.
Yeah,
Different.
inner function
Inner
again.
function.
Inner function, the differentiation is 0, 0 plus 1, which is 1.
1.
That's it, yeah. Simplify it. Simplify it, that's it, yeah. So, plus into minus, minus, you can put it here. Sine pi plus theta, sine theta minus pi, isn't it? This multiplied with this one plus cos theta minus pi, cos pi plus theta. Okay, that's how you have to do. Pretty much very few formulas. This is the one table that you need to remember. Sin x differentiation is cos x minus cos x differentiation is minus sin x,
And
tan
secant
x.
x. Secant x.
Not only that, secant x is the one that you derived it. Similarly, cosecant x
Yeah.
also you have to derive it.
Yeah.
You don't have to remember those formulas. Mainly these are the three formulas. The other formulas you can derive it yourself. Okay, you don't have to remember it. You don't have to remember. That is one formula. And u and v, u multiplied by v.
And
U is a function of x and v is a function of x. What formula you have to use? U by v. U is a function of x, v is a function of x. Okay, how do you do that? Okay, that is one thing. And x to the power of n, that's the main formula. X to the power of n, differentiate that with respect to x. And similarly, n to the power of x also you have to know the formula. N to the power of x. What is the differentiation of n to the power of x with respect to x?
N to the power of x, ln n.
ln n. Okay, that is one thing. And
X
the
to the power
differentiation
of
of
n.
log x.
Uh,
That means ln x.
ln x. 1 by x.
1 by x. Okay, that is another formula you need to remember.
And x to the power of n.
X to the power of n is the main formula. N into x to the power of n minus 1. And the chain rule. Chain rule is like a function having an inner function. So in such case, you start with the outer function differentiation and you start with inner function and then start with inner function. There can be multiple chains. There can be multiple chains. Okay, so for each one, you have to do it like that. Say for example here, we did this one and again we did it. Okay, so somebody says the theta square, or maybe something like theta minus pi whole cube. Then you differentiate it.
Yeah.
This is the differentiation of it.
And then the inner function.
And then the inner function and then the inner function again.
What's that again?
Inner function is a theta minus pi whole cube. So if you differentiate it, 3 theta minus pi square, and then do theta minus pi again. Okay, alright, yeah, we'll leave it here today. I hope you got good understanding. Again, I'm explaining sine theta differentiation is cos theta. Listen, okay, this is sine theta graph. Okay, say assume call this as an f of x, which is equal to sine x. If you differentiate it as per the table, the differentiation is cos x. To understand, to illustrate, or to justify ourselves why we got a cos theta, the reason is we got the sine function. If you see the behavior, the slope is very high at the beginning. As you go to the tip of the sine function, the slope has become 0. Okay, if you plot cos x, the cos x graph follows like this. Okay, so here also for cos x, it started with very high value, and when you come to 90 degrees, it becomes 0. This is nothing but the differentiation of this one is a cos x. Differentiation of sin x is a cos x, because the slope is very high at the beginning. That is why the cos x started with very high value. When it comes to 90 degrees, the cos x value becomes 0. That means the slope of sine function is 0 at 90 degrees. Okay? Alright, yeah. We will stop here and tomorrow we'll continue with a few other problems. Thank you. Bye.